In our second electrostatics video, here we're looking at the net electric field that exists at a point in space from other charges. So here we're not looking at the interaction between two charges, but the field created at a point from one charge. So our equation for this one is that electric field is equal to kq over r squared. When we're talking about electric field, we're just looking at one charge in the equation, not an interaction between charges, and we're focusing on the field at a location. So in this case, the rules for electric field are that electric field points away from positive, and it always points towards negative, because electric field is referencing what happens to a positive charge if you put it at that location. So if we look at our example question here, we have a positive 6 microcoulomb charge, a negative 2 microcoulomb charge. The negative sign, not important in the calculation, but it's going to be important for building our equation. And so we want to find here the electric field at this point P in the middle from these other two charges, which we're going to call A and B. So at point P, if we consider charge A, it's positive, so field's pointing away. So at that location, the field from A is pointing to the right. At this location, we have a negative charge. The field from B is also pointing to the right because it's going to go towards the negative charge. So we have two charges that are creating an electric field that points right at this location. So when we go to our calculation, we're going to say that our net electric field is the field from A pointing right plus the field from B pointing right. When we go to plug that into our equation, we're going to drop our negative signs again, like we did with forces, because we're qualitatively assessing the direction of the electric field. So we get K times QA, 6 times 10 to the negative 6, divided by r squared, so 0.5 squared, plus K times 2 times 10 to the negative 6, divided by 0.3 squared. We can punch that up really quickly. Divided by 0.5 squared plus K times 2 exponent negative 6 divided by 0.3 squared. And here we get a big number for field, but that's okay because that's how field is represented. So I get 4.16 times 10 to the 5th newtons per coulomb, because that's a unit for electric field. And we already decided that our positive direction was to the right. This is a positive number, so we should put a direction on that of right. So the big thing to remember when you set up these questions is that electric field always points away from positive towards negative. That lets it the direction of the fields for the question, and then you build your equation.